Before we get into the complete geography, maps, climate, or landforms, we need to fix our cosmic address. Geography does not begin with states and rivers. It begins with scale. If this scale is clear, later chapters will stop feeling disconnected. So where do we begin? With the Milky Way, Earth's home galaxy. One useful update to retain is that the Milky Way is often placed in the range of roughly 100 to 400 billion stars. Now lock the scale. The speed of light is about 186,000 miles per second. Even at that speed, sunlight takes only about 8 minutes to reach Earth. But the nearest star beyond the Sun, Proxima Centauri, takes roughly 4.24 years for its light to reach us. That is the first mental reset. The universe is not just big, it is staggeringly big. Now shrink the frame to our immediate neighborhood, the solar system. The inner planets are Mercury, Venus, Earth, and Mars. Then come the giant planets, Jupiter and Saturn. Beyond them lie the outer ice giants, Uranus and Neptune. And yes, Pluto is no longer counted as a major planet. It is classified as a dwarf planet. Here's a trap you need to be aware of. Most students only remember the order and stop there. UPSC often tests the exception. Uranus rotates clockwise from east to west. So don't reduce the solar system to a mnemonic alone. Keep one unusual fact attached to it. Now let's move to the moon, because lunar mechanics quietly tests conceptual clarity. The moon's orbit around Earth is elliptical. That gives you two key positions: perigee, the closest point to Earth, and apogee, the farthest. Its orbit is also tilted by about 5.1 degrees to the ecliptic, and that angle matters much more than students realize. Its own axial tilt is small, around 1.5 degrees. And then comes one of the most missed distinctions in astronomy. A sidereal month, roughly 27.3 days, is one complete orbit relative to distant stars. A synodic month, roughly 29.5 days, is one complete cycle of lunar phases relative to the Sun. Why the difference? Because while the moon is orbiting Earth, Earth itself is moving around the Sun. So the moon has to travel a little extra to line up with the Sun again. That extra travel creates the roughly 2.2-day difference. Now come to Earth itself. Earth is not a perfect sphere. It is an oblate spheroid. That means it is slightly flattened at the poles and slightly bulged at the equator. The polar radius is about 21 kilometers shorter than the equatorial radius. And this has a direct effect on weight. At the equator, weight is slightly less because centrifugal force is greater due to maximum rotational velocity. At the poles, weight is greater because rotational velocity is zero and the radius is shorter, so gravitational pull is stronger. And if UPSC asks for evidence that Earth is spherical, you already have a checklist. Circumnavigation, circular horizon, the way ships appear and disappear, sunrise and sunset patterns, lunar eclipses, and even aerial imagery. Now separate two things that students mix up all the time: latitudes and longitudes. Latitudes are parallels. They measure angular distance from the equator. They are equally spaced, roughly 111 kilometers apart for every degree, and their circumference decreases as you move toward the poles. The key latitude lines you must retain are Equator, Tropic of Cancer, Tropic of Capricorn, Arctic Circle, and Antarctic Circle. Longitudes are meridians. They are semicircles joining the north and south poles. And here's a trap you need to be aware of. The distance between longitudes is not equal everywhere. It is maximum at the equator and converges to zero at the poles. Also retain two terms clearly. Graticule means the network of latitude and longitude lines. Great circles are imaginary circles dividing Earth equally, and that includes the equator and all meridians. Now bring motion into the picture. Earth rotates from west to east. That single fact explains why places to the east experience sunrise earlier and therefore gain time. This is where the standard rule comes from. East gains, west loses. The prime meridian or Greenwich meridian is 0 degrees longitude and passes through London. India's standard time is based on 82.5 degrees east, which makes it Greenwich Mean Time plus 5 hours 30 minutes. And then comes the international date line, around 180 degrees longitude. Crossing it changes the calendar date by exactly 1 day. If you don't lock west to east rotation first, time calculation becomes guesswork. Now separate Earth's two motions cleanly: rotation and revolution. Rotation is the spin. It happens from west to east, takes 24 hours, and gives you day and night. Its velocity is maximum at the equator and falls to zero at the poles. Revolution is the orbit. It takes 365.25 days, follows an elliptical path around the sun, and gives you the year and the seasons. But revolution alone is not enough. The axis remains tilted in the same direction throughout the orbit. This is called parallelism of the axis, and it points toward Polaris, the pole star. And here's a trap you need to be aware of. Polaris is not the brightest star in the sky. Sirius is. That is the kind of detail UPSC uses to punish lazy revision. Now let's understand the geometry of the tilt. Earth's axis is inclined 23.5 degrees from the perpendicular. The same thing can also be expressed as 66.5 degrees to the orbital plane. And this angle decides where vertical rays of the sun can fall. 23.5 degrees north and 23.5 degrees south are the absolute maximum limits for vertical rays. That is why the Tropic of Cancer and Tropic of Capricorn matter. The rule is simple. At the two tropics, vertical rays fall once a year. At all locations between them, vertical rays fall twice a year. If you understand this geometry, solstices and equinoxes stop being dates to memorize. Now we move into the solstices. At the summer solstice, around June 21st, Earth's axis leans toward the north. Vertical rays fall on the Tropic of Cancer. That gives the longest day in the northern hemisphere. At the same time, the North Pole gets 6 months of continuous daylight, while the South Pole enters 6 months of darkness. At the winter solstice, around December 21st or 22nd, the axis leans south. Vertical rays fall on the Tropic of Capricorn. That produces the shortest day in the northern hemisphere, while the polar day-night pattern reverses. And one practical way to remember the daylight effect is this. At the summer tropic, day length is around 14 hours. At the equator, around 12 hours. And at the opposite winter tropic, around 10 hours. Now come to the equinoxes, the equal night positions. They occur around March 21st and September 21st or 23rd. On these dates, the sun is vertically overhead at the equator. Neither hemisphere leans toward the sun. That is why the effect is global. All parts of the world experience equal day and equal night, roughly 12 hours each. And yes, the date shifts slightly because a true solar year is 365.25 days, not a flat 365. Now answer a very basic looking but high yield question. Why are summers hotter and winters colder? In summer, the rays are more direct. That means heat is concentrated over a smaller area. Days are also longer, so Earth receives more energy and loses less during the short nights. In winter, rays are oblique. They pass through more atmosphere, suffer more absorption and scattering, and spread over a larger surface area. At the same time, nights are longer, so more heat is lost than gained. This is not just summer equals hot, winter equals cold. It is a balance of angle, concentration, atmospheric path, and duration. Now let's close one of the most commonly confused ideas: eclipses. A solar eclipse happens when the alignment is Sun to Moon to Earth. So the Moon comes in the middle, blocks sunlight, and this can happen only at new moon. A lunar eclipse happens when the alignment is Sun to Earth to Moon. So Earth comes in the middle and the Moon falls into Earth's shadow. This happens only at full moon. A clean way to retain this is solar equals moon in middle, lunar equals Earth in middle. And now the deeper question. Why do we not get eclipses every month? Because the moon's orbit is inclined by about 5.1 degrees to Earth's orbital plane. So perfect alignment is rare. That angle is the real gatekeeper. Finally, let's talk about dawn and twilight. Twilight is the brief period of diffused light when the sun is technically below the horizon. The physics behind it is Rayleigh scattering. Sunlight is scattered by particles in Earth's atmosphere, so light still reaches us even before sunrise and after sunset. Now the important geographic effect is latitudinal. At the equator, the sun rises and sets along a steeper, more vertical path, so twilight is short. At temperate and polar latitudes, the sun follows a shallower, more oblique path, so twilight lasts much longer, longest near the poles. That's why dawn and twilight are not just atmospheric optics. They are also a latitude concept. If you can connect scale, shape, motion, tilt, seasons, eclipses, and twilight in one sequence, then this chapter is no longer a collection of facts. It becomes one system, and you are set for revising the complete geography.